Good day to Dr. Mohammad Zafri. So, my name is Mahindrusaiee EE0104490 Ravi, and I am from the group of three peoples, where Mr. Arvinth Sivaji, who is the leader, and Mr. Danessha, who is another member as me. So, today we'd like to inform about the mass detector. We chose the mass detector as our AI applications. So the problem statement, where and why we choose the mass detector as the main artificial intelligence application. So actually, as the COVID pandemic has been took over the world, so we in our daily life we need to use the mask. So we thought the mask detector could help uh, many peoples to identify whether they are wearing a mask or not, and this will help the government to identify who and who is not wearing the mask. The application of the artificial intelligence today we have used in four ways, where the first one with no mask and it will show please wear a mask, and the second one it will be showing a person uh, with a mask where it will be showing thank you for wearing the mask as an appreciation. And then we can see another person who will not wearing a mask and eating, and at that moment it will be showing enjoy your meal. And then the last one we can see the people who is drinking a water without a mask, and it will pop up as enjoy the drink. So we'll know what is the person is doing. Okay, so we have totally used around 251 images. So in the 251 images, without a mask we have include around 89 images, with a mask 66, without a mask and eating 45, and without a mask drinking would be 51. So the total will be 251 to get the right to get the AI to detect. Okay, and this is the dataset structure we used to train the AI applications to understand more about the humans who are wearing mask or without wearing mask. So that's all from me, and I would like to.
Danessha, and today I'll be talking about the activities that was carried out to complete task 3. Task 3 was conducted on teachable learning, where a total of 4 classes were created categorizing as mask, no mask eating, and no mask drinking. The goal of this work is to minimize errors and loss while maximizing model performance with appropriate hyperparameters, which is classified as epoch, bell size, and learning rate. Therefore, the epoch was set to be 49, followed by batch size at 64, and initially learning rate was set to 0.005. As after training, we tuned the learning rate to 0.1, 0.001, and 0.0001 to obtain the accuracy per class and the confusion matrix. This proves the benefits of hyperparameter tuning to be reducing the number of losses and errors while increase the model performance and as well.
Well, I'm going to show the demonstration in teachable machines. Teachable machines is where we added our data to train the model. So there are 4 data sets which are no mask, classes of data sets: no mask, mask, no mask eating, and no mask drinking. And after all this data is being put into this black box, and this will train the model. So there are some hyperparameters that we set here, and the reason for the hyperparameters has been explained in the previous slides. So this will show the output after it's being trained. Right now we're in NUMA, so it will be 100%, and we can export this model to P5.js to create a user interface. So as P5.js, I now mask status is showing that the confidence level is 0.9, and the instruction should be please wear a mask. And this action that I'm going to do is I'm going to wear a mask. So the confidence level is 0.99, almost to 1, and the instruction is thank you. Well, since like a lot of people wouldn't wear a mask when they're drinking, we have to cut down some slack. So I'm gonna drink something, will show no mask drinking, and the instruction will be enjoy the drink. So let's say I'm eating something, it will show no mask eating, and the instruction will be enjoy the meal. So this is what basically the mask detector does. Now I'm going to explain the coding a little bit. So we first have to configure the labels. So first the label is actually the results of from the status, and we have to add like confidence and top color too. And we actually have to add them in the bottom again to make sure that we can use it as a label. It's here. So the label is actually results from this output, and the confidence is the results, and how sure is the result is the confidence. So we can use them as a label. And our canvas is 700 or 700, and the video size is 450 and 250. So, and its print subject is ready. What is it doing is a console, and this will make sure that the mask detector is ready to work. And this is for the background colors, and this rectangular is for the label for the videos, and also the label for the actions. And draw the video and instruction, and this is for the text size for the instruction over here, and these are the coordinates of where it will be. And this is for the text size and colors of the text for mark status and confidence level. And, and this is in if instruction, like if the label is no mask, it has to show please wear mask. This is where we do this. So if the label is mask, thank you and all that. I've already explained this label and confidence. These are basically the results that we're using to make sure that we get an output that we want. So I'm also going to explain the conclusion. So from this project, we concluded that the AI application is successfully run, and we can identify if a person is wearing a mask. And we also gain a knowledge on teachable machines and hyperparameters to train a model. And it also serves as a good introduction for us to P5.js. And we hope to use it for the future projects. And that's all from us. Thank you so much.